Go. Go. Nope, I don't want algebra. Oh, that's a terrible x-axis. Okay, welcome, good afternoon. I am so excited because Thanksgiving break is almost here, but I wanted to get in one last math minute. Actually, I may try and post one next week with the results from the giveaway that we've been doing. So if you do not know, this is the fifth in a series of 5 videos where my social media team told me, you know what, you really need to run a giveaway. And so I am giving away this amazing iPhone 8 box. So if you would like this iPhone 8 box signed by yours truly, you know, with stuff inside it, I don't know what's inside it, like this video, subscribe, and comment on one of the last 5 videos. So that's Math Minute number 18, number 19, number 20, number 21, or the one that I'm doing right now, number 22. I really hope I have that numbering right, but I'm pretty sure that I do. Please comment on those if you're interested in entering that giveaway. My next Math Minute will show you how I design an Excel spreadsheet to randomly choose among those videos and their comments. I'll put the video links in the description below so that you can make sure you are commenting on the correct videos. Anyway, just a quick one today, always a quick one. Math Minute, guaranteed to be no more than 10 minutes long, guaranteed to be today. I wanted to look at one other way to understand the Pythagorean identities. So you may remember we looked at this right triangle, also called a reference triangle, in the unit circle. We used the relationships in a right triangle, namely Pythagorean theorem, a² plus b² equals c², and we used that information to generate these 3 identities. Sin² theta plus cosine² theta equals 1, 1 plus cotangent² theta equals cosecant² theta, and tangent² theta plus 1 equals secant² theta. There's this other triangle, and it still exists in the unit circle, but it's kind of extended. So this is, again, our reference triangle. You can see there in the middle, we've still got the 1, the sine theta, and the cosine theta, but I've kind of extended and built another right triangle around it. If you want to situate this in the unit circle, you can see that's what it ends up looking like. The coordinate plane would be right here, with the origin right there at the center, and we get these other lengths. There are these 3 other trigonometric functions, or if you're only thinking about sine and cosine, there are 4 other trigonometric functions. There is tangent, which is a tangent to the circle. That's why we call it tangent. It's just this portion right here. There is cotangent on the other side. There are a couple different reasons you might imagine that's called cotangent. I'm not going to get into those right now. And then there are these 2 lines. This total base now going out to the tangent itself is called secant and measures secant theta, the secant of whatever the angle is. And this up and down distance here is cosecant theta. The reason this is interesting to me is that in this picture lives all 3 of the Pythagorean identities. Of course, you should already notice what we talked about last time. The sine, cosine are legs of a right triangle with a hypotenuse of 1. So of course, sine² theta plus cosine² theta equals 1. But you might notice there are some other right triangles in this figure right now. I can look at just this right triangle here, and I can see, all right, so we've got a length of 1, another leg of tangent theta, and then the hypotenuse is secant theta. And so that is where we get 1² plus tangent² theta equals secant² theta. Of course, we don't normally say 1², we normally just say 1 plus tan² equals secant² theta. You can also probably tell, oh, there's also this big right triangle here that relates cotangent, 1, and cosecant. You can see 1 in that case is yet again another length, and so again we could say 1², cotangent, also another length there, cotangent² theta, and cosecant in that case would be the hypotenuse, cosecant² theta. And again, we don't normally say 1², we usually just say 1, but that figure actually shows us all 3 of the Pythagorean identities. You might notice it shows us a lot of other interesting relationships. We could say something right now, so additional challenge to you. What could we say about cosecant² theta and secant² theta related to cotangent theta plus tangent theta as the hypotenuse of that really large right triangle? But there's one other way I really like this figure, which is, let's actually look at Here we go. Let's actually look at this. Oh my gosh, where did all this come from, right? So you may have done geometric means in your geometry or algebra 2 class. Oh, by the way, in the last video, I don't know why I did this, but I kept saying, oh, if you're in Algebra 2 right now, you're looking at these trigonometric identities. That's probably not true. You do look at trigonometric identities typically toward the end of Algebra 2, trigonometric functions and the identities and so on. But really, if you're doing it at this time of year, you're probably in pre-calculus. So to anyone that I misled in the last video, my apologies. But in any case, if you're in that Algebra 2 class or you're in a geometry class, you might have started to look at geometric means. What you've looked at there is that when we draw a right triangle like this, and we look at these lengths along the hypotenuse, so you'll notice that bottom length is actually the hypotenuse of the overall triangle, h is what we call the geometric mean of L and M. So h² is equal to L times M. And then we get these other relationships. J is the geometric mean between L and the total length along the hypotenuse there, L plus M. That's this relationship I've got here. K is the geometric mean of M and the total length. And so you can see over here, K² equals M times the sum L plus M. So what we should be able to do is to take those various geometric means and also generate our Pythagorean identities from those geometric means. So for example, here, what you should notice is, oh, well, 1² would be the geometric mean between tangent theta and cotangent theta, which is absolutely true. 1², of course, does equal tangent theta times cotangent theta, because of course tangent theta and cotangent theta are reciprocals. But we can also say things like, oh, well, cosecant theta is the geometric mean between cotangent theta and the total hypotenuse there, cotangent theta plus tangent theta. Well, what does that end up looking like? It would say cosecant² theta equals cotangent theta times the sum cotangent theta plus tangent theta. Well, that's interesting because if we distribute the cotan theta right now, you'll notice we end up with our other one of our other Pythagorean identities. Cosecant² theta equals cotangent² theta plus 1. Because again, when we multiply cotangent theta times tangent theta, they're reciprocals. They're going to give us back 1. Unsurprisingly, if we do the geometric mean on the other side, if we take a look at secant theta, then what should end up happening is secant² theta. Secant theta is going to be the geometric mean between tangent theta, this small length right down here, and again, that hypotenuse, which was tan theta plus cotan theta. And once again, if we distribute there, we get secant² theta equals tan² theta plus 1. Tan theta times cotangent theta, again, is 1. So all of which to say, you can see there are quite a few ways, if we actually understand what's going on, to generate these Pythagorean identities. It's not that memorizing them is somehow bad or wrong, it's just that memorization typically is not as good as understanding what's actually going on. So if we have this picture in mind, if we have some sense of the different trigonometric relationships in the unit circle, we should be able to generate most of the identities, if not all of the identities, from scratch. Again, that's not to say that it's not also useful to simply have them memorized. I don't typically generate my sum and difference identities from scratch, for example, but if I needed to, I could, because I have understanding, and understanding is better than memorization. In any case, I'm sending you off to Thanksgiving break with that in mind. I hope that you enjoy that trigonometry. I can't think of any additional challenges right now beyond what I said earlier. Take a look at this figure. Show me what other kinds of Pythagorean relationships you can come up with. Like the video, subscribe if you want to see more Math Minutes, guaranteed to be no more than 10 minutes long, guaranteed to be on whatever day it is that I post them. Any of the last 5 videos, again, giveaway, any of the last 5 videos, Math Minute number 18, Math Minute number 19, 20, 21, and 22, and you could win that iPhone 8 box. And look forward next week to Math Minute number 23, where I show you how to build an Excel spreadsheet that will randomly choose among things. In this particular case, any of the 5 videos at random, and any of the comments on those videos, again, at random. I'll link the videos below if you're super interested in that box, which, why wouldn't you be? Who doesn't want an iPhone 8 box?